We shall discuss few problems of all kind like algebraic function, trigonometric function, exponential function, logarithmic function. One by one we'll discuss. Some place we'll use L'Hopital's rules. Some places we will use direct factorization method or whatever the method in that particular function. Now in an algebraic function, when I replace x by 3, I get 0 by 0. Our old method was find the common factor. X minus 3 is the common factor, and that was a technique we used. But you can see that here the derivative method will reduce our steps. Let's have a look at it. Limit x tending to 3. When you differentiate in this one, 3x square minus 4 divided by 3x square plus 2x minus 6. Now we'll replace x by 3. So 3 into 3 square minus 4 upon 3 into 3 square plus 2 into 3 minus 6. So 9 into 3, 27 minus 4 divided by 9 into 3, 27 plus 6 minus 6. So 23 by 27. So we can calculate the limit very fast by using this technique. Again, this is a pure trigonometric function. Usual method of evaluation is getting the common factor, but it takes time and you need to know all the formulas of trigonometry. So it's very simple to do by the derivative method. First of all, you notice that the numerator and denominator becomes 0 by 0 on direct substitution of x by pi by 4. So I differentiate the numerator, derivative of 1 minus tan x divided by derivative of 1 minus root 2 sin x. So when you differentiate the numerator, you will get minus x square x, and when you differentiate denominators, minus root 2 cos x. On replacing x by pi by 4, you will get minus x square pi by 4 divided by minus root 2 into cos pi by 4. So we can cancel off this both. That is root 2 square upon root 2 into 1 by root 2. So my answer became 2. So very fast we get the answer. We are very familiar with this formula. Limit theta tending to 0, sin theta upon theta is 1, and limit theta tending to 0, tan theta upon theta is 1. Same way you can reverse reciprocal also, you can do it. And further we can say limit theta tending to 0, sine of k theta upon theta. We know how do you apply this formula? What are the conditions to apply this formula? When you apply the limit, the angle part should tend to 0. The angle part should tend to 0, and the denominator and the angle part should be same. Then your answer should be 1. And remember, this theta should be in radians. So if I have sine k theta, when I apply the limit here, this tends to 0. But the denominator and the angle part of sine are not same. So what I do is I divide and multiply by k. So now this part became 1. So my answer becomes k. So remember this, limit theta tending to 0, sine k theta upon theta is k. So first you tell me limit theta tending to 0, sine 4x upon x will be 4. Limit x tending to 0, tan 3x upon x will be 3. Whatever the number here, the same will be your answer. The coefficient becomes your answer. Now, one more formula that I want to discuss here is, so let me write down the two formula which I have discussed here. One is limit theta tending to 0, sine k theta upon theta is k. Second is limit theta tending to 0, sine tan k theta upon theta is k. Next, one more formula that I am going to discuss is limit theta tending to 0, 1 minus cos k theta upon theta square. This also we will learn it as a standard formula. If you differentiate this with respect to theta, cos becomes sine, so plus sine k theta into k upon 2 theta. Now this became k, so 2 into k upon, this part became k, sine k theta upon theta is k, so k into k upon 2, so this become k square by 2. So you can tell me fast, limit x tending to 0, 1 minus cos 4x upon x square. Remember, denominator should be x square, x will not work. Then 4 square by 2, so 8 becomes your answer. Limit x tending to 0, 1 minus cos 3x upon x square. So answer will be 3 square upon 2. So every time we will apply this formula directly. Limit theta tending to 0. 1 minus k theta upon theta square is k square by 2. K square by 2. If you forget the formula, use the derivative method. Now we come to few questions on inverse function. What will be limit x tending to 0 sine inverse of x upon x? So what happens when I put x as sine theta? If I put x as sine theta, as x tends to 0, theta also will tend to 0, because when x is 0, theta is also 0, sine 0 is 0. So I can say this as limit theta tending to 0. In place of x, I am writing sine theta. So this will become limit theta tending to 0, sine theta upon sine theta. Sine theta upon theta is 1, so theta upon sine theta is also 1. So my conclusion, limit x tending to 0, sine inverse of kx upon x is k. Similar to this, limit x tending to 0, tan inverse kx upon x is also k. So these are the formulae that you need to know other than just finding the derivative. We have sine 3x and 1 minus cos 4x. 1 minus cos theta, when you have denominator, should be theta square, whereas sine requires only one power. So first step is you will split this as x and x square. Now you can write the answer for this. Answer for this is 3. You can write the answer for this. K square by 2, k square by 2, 4 square by 2. So answer became 3 into 16 by 2, 3 into 8, 24. Like this you need to answer it. I will be giving in the worksheet lot of questions like this to answer it so that you become expert in it. Now in this problem, one method is you can find the derivative. So limit x tending to 0, derivative of cos. If you are not familiar with trigonometric formula, derivative method is easier one. Minus sine 3x into 3, and this will become minus of minus plus sine 4x into 4, and this will become 2x. So now I can write, when I take this both, my answer would be minus 3 by 2, that is just sine theta upon theta. Okay, I'll limit x tending to 0. This much I am taking separately. So I have minus 3 by 2 sine 3x upon x. And when I take this separately, I will have 4 sine 4x upon 2x. So I can write this as 3. So my answer is minus 9 by 2 plus. When you take this as the answer, this will become 4. So 16 by 2. 4 into 4 divided by 2. So that becomes minus 9 plus 16 gives you 7. So 7 by 2 becomes your answer. So this is very easy to apply this method. If you don't like this method, next method is apply cos c minus cos t formula. If you apply cos c minus cos t formula, 2 sine sum 7x by 2 into sine b minus c by 2, 4x minus 3x. So x by 2 divided by x square, 1x here, 1x here. This answer is 7 by 2. This answer is 1 by 2. So this will get cancelled and answer gives you 7 by 2. Any method you can apply, whichever you feel easier to apply in that particular case, you apply. In this problem, 1 minus cos we have seen. 1 minus cos requires theta square. So I will write this way, limit x tending to 0, 1 minus cos 3x upon x square divided by x tan 2x divided by x square. Because 1 minus cos, if I see any time, the denominator should be x square. So I divided numerator and denominator by x square. Now I can write my answer here. This answer is 3 square by 2 and this answer is 2. So 9 by 4 is your answer. This problem, either you can do derivative method or by trigonometric formula. Trigonometric formula is easier. Have you noticed that degrees are not matching? What do you mean by degrees are not matching? If you have sin x, you should have x. If you have 1 minus cos x, we should have x square. We call it degree matching. If the sin x is there and degree is cube, which means it's equal to like this. Degrees are not matching. Or if you may have here cos 2x upon x cube, degrees are not matching. We call such cases degree not matching. So whenever degrees are not matching, you are supposed to manipulate the numerator, or you can do the derivative method. Both the methods are fine. So I can do this way, limit x tending to 0, 2 sine x minus 2 sine x cos x. I have applied the trigonometric method. What is sine 2 theta? 2 sine theta cos theta. Now I can take 2 sine x common, 2 sine x common. So 1 minus cos x, x cube I'll split as x and x square. Now degrees are matching. Degrees are matching. 1 minus cos x requires x square. Sin x requires x. Now this became 1. So 2 into 1 into half. How do you get half? Here 1 square by 2 it is. So your answer is 1. This way we can do it fast. Two methods. One is substitution method and other is by using derivative method. First I'll show both the methods so that you, whichever convenient for you, you can apply. Substitution method, what you do is put h as x is tending to pi by 2. So the value of x is little more than or little less than pi by 2. If h is positive, little more. If h is negative, little less. Whatever said and done, as x is tending to pi by 2, h will tend to 0. So this will become limit x tending to 0, 1 minus sine pi by 2 plus h divided by, instead of x I am going to write pi by 2 plus h, so pi minus 2 into pi by 2 plus h, the whole square. And that became limit h tending to 0, 1 minus cos h, sin 90 plus theta. Sin 90 plus theta is cos theta. And denominator became pi and pi get cancelled, 4h square. How it became 4? This 2 and pi by 2 get cancelled with this pi. This 2 will become minus 2h. When you square it, become 4h square. Now we know the answer for this. The answer for this is 1 by 4 into k square by 2. K here is 1. So 1 square by 2. So 1 by 8 becomes your answer. This is one method of doing the problem. Another method of doing this problem is by derivative. The derivative method is you just differentiate the numerator. It becomes minus cos x divided by 2 into pi minus 2x into derivative of pi minus 2x. So a minus 2 will come. Now this minus and this minus will get cancelled. If I replace x by pi by 2, cos pi by 2 is 0. If you replace x by pi by 2, this also will become 0. It is 0 by 0. So I can again differentiate once more. So this became limit x tending to pi by 2. The derivative of cos x minus sin x. 2 into 2, 4. Pi minus 2x derivative is minus 2. So I can write. So it became, when you replace x by pi by 2, minus sin pi by 2 upon minus 8. That is 1 by 8 becomes your answer. This method also we can apply. By now you must have got the idea that if there is a square in the denominator, the derivative method will have to apply 2 times derivative. So either this also you can do either substitution. If you are doing substitution, you have to put x as 1 plus h and replace x by 1 plus h and you can calculate it. This is one technique. Second method is just do the derivative method. I prefer you to do derivative method as long as the power is up to 2. The derivative of this will be minus sine pi x into pi. And the denominator derivative is 2 into 1 minus x into minus 1. When you do the derivative, be careful about all these minus signs. Now this became pi by 2 into limit x tending to 1 sine pi x upon 1 minus x. Now again, now derivative is very simple here because now next derivative 1 minus x is going to become minus 1, a constant is going to come. No more it is going to be 0 by 0 after the next derivative. Now at present it is 0 by 0. So pi by 2 into, when you differentiate next time, it becomes pi into cos pi x upon minus 1. Derivative of 1 minus x is minus 1. Now this is no more 0. You have noticed beginning it was 0. After first derivative it was 0. Now second derivative it will not be 0 because the power 2, second derivative will become constant. Now this became pi by 2 into pi, x became 1 cos pi upon minus 1. You know cos pi is minus 1. So your answer is pi square by 2. This is minus 1. So minus 1 and minus 1 will get cancelled. Hence answer is pi square by 2. This problem also has got 2 methods. One method is you can put x as pi by 2 plus h and then apply sin theta upon theta formula. Another method is you can directly just find the derivative Let's check which method is better. First I am going to find the derivative method. Minus 3 sin x minus 3 into sin 3x divided by 3 into pi minus 2x the whole square into minus 2. Now because it's cube, you will have to differentiate 3 times to come to the final answer. So again you will be getting 0 by 0 if I directly substitute, because you can see if I replace x by pi by 2, this becomes 0. So once more I will find the derivative. So that became minus 3 into derivative sin cos x. This 3 into 3, 9 cos 3x divided by minus 6 into 2 times pi minus 2x into minus 2. You substitute here, this becomes 0, this will become 0, cos 90 is 0, cos 270 is 0. So again 0 by 0. So I will differentiate once more. Limit extending to pi by 2 become 3 sin x cos derivative minus sin, minus of minus plus. This will become 27 sin 3x divided by 12 into 2, 24. Derivative of pi minus 2x, another minus 2. Now when I replace this, it become 1. This become minus 1. So 3 into sin pi by 2 plus 27 into sin 3 pi by 2 divided by minus 48. This 3 into 1 minus 27 divided by minus 48. Sin 3 pi by 2 is minus 1, that's how it is minus 27. So your answer became minus 24 upon minus 48. So the final answer is 1 by 2. 1 by 2 becomes your final answer. Let's see if I do by substitution method, what will be the answer. This is the derivative method answer. Now when I do substitution method, this is how I will be proceeding. I will be putting x as pi by 2 plus or minus h, anything you can write. I put pi by 2 plus h. So this became limit h tending to 0. 3 cos pi by 2 plus h plus cos 3 times pi by 2 plus h divided by pi minus 2 into pi by 2 plus h the whole cube. This will be your answer. Now let's have a look at each one of them. What will this turn to be? This is limit h tending to 0. Cos 90 plus theta, that comes in second quadrant, so minus 3 sin h. This will become 3 into pi by 2 plus 3h. You know that cos 270 plus theta comes in fourth quadrant, so cos is positive, but it will change to sine. So sine 3h divided by pi minus 2h the whole cube. So this will get cancelled. Now I can write this as limit h tending to 0 minus 3 sin h. Now I am going to put sin 3 theta's formula. 3 sin theta minus 4 sin cube theta. Why did I do that? Because degrees were not matching. Sin theta requires only theta in the denominator. Sin 3h only requires 3h in the denominator. Don't require cube. Whenever the degrees are not matching, what you should do? Manipulate it. 3 sin h will get cancelled and denominator become h cube. So I will be getting minus h cube because there is a minus sign here. So my final answer now will be, I will write with a different color, limit h tending to 0 minus 4 sin cube h divided by minus 8 h cube. Now this cube can be made as whole cube. So sin theta upon theta. So 4 by 8, answer is 1 by 2. Any method you can apply. You can also apply derivative method over here. So it is up to you which method to apply. If you feel more convenient with the trigonometric formula, you can apply this method. If you find more convenient with the derivative formula, if the degree is 1, so if the degree is 1, derivative method is the best method. So differentiate the numerator. So limit x tending to 1. Remember, when I replace x by 1, sin pi is 0. When I replace x by 1, 1 minus 1, that is also 0. So you will be getting 0 by 0. So since it gets 0 by 0, I can apply the derivative method. Sin pi x is cos pi x into derivative of pi x, so 1 pi will come. Into derivative of x minus 1 is 1. Replace x by 1, so cos pi into pi, so minus 1 into pi gives you minus pi. This gives your answer. One more problem I'll do with this. Limit x tending to, let's say, pi by 6, cos x minus root 3 sin x divided by pi minus 6x. Here also substitution, both of them you can apply substitution method, but this degree, whenever degree is 1, the derivative method will be the easiest method. So I will find the derivative of the numerator, derivative of cos minus sin x, derivative of minus root 3 into derivative of sin x, that is cos x, upon minus 6. Derivative of pi is 0, derivative of minus 6x is minus 6. Now replace the limit, minus sin pi by 6, root 3 into cos pi by 6, divided by minus 6. That is sin 30 minus half, minus root 3 into cos 30 root 3 by 2, divided by minus 6. So minus half minus 3 by 2 divided by minus 6. Minus 4 by 2 divided by minus 6. So you get 2 by 6, that is 1 by 3 becomes your answer. So derivative method will be always an easier method for ones with a degree 1. If degree is more than 1, so you may have to differentiate towards